Hi everybody, and welcome to your first official video lesson of your 6th grade school year, which is the basic divisibility rules. Now, like every video lesson we'll have this year, this is going to go through a little bit of an explanation of what divisibility is, give you some examples to understand it better, take you through the divisibility rules, and have some things to practice on it afterwards, as well as have a reflection question at the end. This video lesson in particular, I'm going to give you lots of prompts in terms of things to write down and things to make sure to take note of in your notebooks so that you start to get an idea of the types of things that need to be written down in video lessons, although you're certainly welcome to write down more than I prompt you to. Anytime I say pause the video and write this down, that is something that I will expect to see in your notebook when you get to class either tomorrow or over the weekend or whenever it is that you happen to be watching this. So first, let's then get into what divisibility is. We can't talk about divisibility rules until we know what divisibility means, and as you might have guessed by the first part of that word, divisa, which shares a root with division, it does have to do with division, but specifically it has to do with division without remainders, which may not seem too particularly noteworthy, but it turns out that being able to divide things without having remainders or without having extras is really a fundamental part of a lot of what we're going to do in math this year and for the next few years. So to give you an example of what I mean, let's take a look at some apples. Now, if we wanted to split these apples into two groups, we could do that pretty easily. And we could see, even just by counting, that because we have 12 apples, we can divide them into two groups of 6. So the number 12, these 12 apples, can be evenly divided into two groups. Now, if we did the same thing with 3 groups, we would find something very similar. These apples can be split evenly into 3 different baskets, or between 3 different people, or into 3 different groups. So these 12 can be divided evenly, or using the word divisible, are divisible by 3 baskets. The same thing we can look at it if we have 4 baskets. That's not what I wanted to do. There we go. If we have 4 baskets, we can divide it evenly, but if we tried to do it with 5, we would find that we could give 2 apples to each of these 5 people or each of these 5 baskets, but then we would have a few left over. And so 12 cannot be evenly divided into 5 baskets. And so that's what we're talking about in terms of divisibility. Sometimes we can divide numbers evenly, and sometimes we can't. Divisibility rules talk to us about when that division is possible and when we can have that division without a remainder. So there are 2 major terms we need to talk about. First is a divisor or a factor. And when we have one number dividing evenly into the second number, we call it a divisor. 12 can be divided by 3 without a remainder. So 3 is a divisor of 12. I'm going to ask you to write this down in just a minute, but not quite yet. If we were going to go the other way and talk about 12 related to 3, 12 is not a divisor of 3 because 3 goes into 12. Instead, we say 12 is divisible by 3, which means that one number is divisible by another if the second is a divisor of the first. This is all talking about division without remainders. So this is the first time I'm going to ask you to go ahead and pause the video, write down the definitions for divisible and for divisor or factor. Please write down both, and unpause the video when you're ready to move on. So now that we've written down those 2 different definitions and we started to get an idea about how they're used and what they mean, let's get into a few of those divisibility rules. And the purpose of the rules is to figure out when we can divide something by a number and get no remainder. So if you thought about what sorts of numbers can we divide by 2 without a remainder, you would eventually come up with a conclusion of, well, if a number is even, we can divide it by 2. That's actually the definition of an even number. So the divisibility rule for 2 says that if a number is even, it's divisible by 2. It can be divided without remainder. So pause the video, write down the divisibility rule for 2, and come back when you're ready to move on. So to give a few examples of this, the number 10 is even, so it is divisible by 2. The number 74 is even, so it's divisible by 2. The number 1,397,460 is even, so it's divisible by 2. Notice that this rule doesn't tell us what the quotient actually is. It just tells us that we can do this division without a remainder. On the other hand, 17, not divisible by 2 because it is not even. For 3, we have a slightly different rule. The divisibility rule for 3 is about the sum of digits. So we take all the digits of a number, and that sum, when we add those digits together, is divisible by 3, then the number itself is divisible by 3. So go ahead, pause the video again, write down the divisibility rule for 3 as you see it, and then come back and we'll do some examples to show you what that means. So let's take a few different 3 or 4 digit numbers here. 171, 396, 4,210, and 3,972. So now when we talk about the sum of the digits, we really mean breaking the number apart. So we have 1 plus 7 plus 1, 3 plus 9 plus 6, 4 plus 2 plus 1 plus 0. The digits, of course, being those single numbers that make up the pieces of a number in our place value system. Well, for 171, 1 plus 7 plus 1 is equal to 9. 9 can be divided by 3 without a remainder, so 171 is divisible by 3. For 396, 3 plus 9 plus 6 is 18. 18 can be divided by 3 without a remainder. Therefore, so can 396. 4,210, that sum is 7. 7 is not divisible by 3. So 4,210 is not divisible by 3. And then when we add up 3,972, we end up with a sum of 21. 21 is divisible by 3. Therefore, so is 3,972. Moving on to the next divisibility rule for 4, it's similar to 2, but not quite the same. In this case, we're looking for the last 2 digits of the number being divisible by 4. Then the number itself is divisible by 4. Go ahead, pause the video, write this down, and then we'll come back and see an example of what I mean. So let's take 3 different numbers here. 312, 713, 648. Now for the divisibility rule for 4, we're looking at the last 2 digits, so just the 12, the 13, and the 48. Not as the sum of the 2 digits, but the 2 digits themselves as a separate number. In this case, 12 can be divided by 4, so the entire 312 can be divided by 4. 13 cannot be divided by 4, at least not evenly, so 713 is not divisible by 4. 48 divided by 4 is 12 without a remainder, therefore the entire number 648 is divisible by 4. For 2, we have just the last digit. For 3, we have the sum of digits. And for 4, a whole different type of rule where we take the last 2 digits and hold them out separately. We have 2 more divisibility rules to talk about, but they're ones that you're particularly familiar with. Divisibility rule for 5 is divisible by 5 if it ends in 5 or 0. So go ahead, pause the video, and write this one down. And this is one you've seen before. You know if a number ends in 5 or if a number ends in 0, then you can, in fact, divide it by 5 without a remainder. Or you've noticed when you've counted by 5, 5, 10, 15, 20, 25, 30, etc., that all of those numbers, the multiples of 5 we call them, all end in 5 or 0. And then I'm going to have you fill in one here for a second. The divisibility rule for 10, how do we know if a number is divisible by 10? So pause the video, fill in the blank. If a number blank, then it is divisible by 10. And of course we know we can divide it by 10 if a number ends in a 0. If it doesn't end in 0, when you divide it by 10, you're going to get a remainder. So what we're going to do now, as a matter of practice, is you're going to fill out what I call a divisibility chart. So the example here that I give with 20 is we're going to use an X or a check to show the green numbers on the left being divisible by the numbers on the right. So for 20, 20 is divisible by 2 because 20 is even. 20 is not divisible by 3 because 2 plus 0 is 2, and 2 is not divisible by 3. But it is divisible by 4. It is divisible by 5 because it ends in a 0, and it is divisible by 10. So we've added an X in the columns that 20 is divisible by the numbers in red at the top, and left it blank where there is not one. So go ahead, copy this chart down, fill it in, and come back when you are ready to see the answers. So I'm going to switch to the next page now. If you haven't finished it yet, please pause the video and finish it to show you which numbers are divisible by what. And what we can see is that 24 is divisible by 2, 3, and 4, but not 5 and 10. 40 is divisible by everything except 3, much like 20. 150 is divisible by 2, 3, 5, and 10, but not 4. And the row with 17 should be blank because it does not fit any of the divisibility rules. And so if you got any of these wrong, I'd encourage you to go back into your notes, look at the rules again, see what mistakes you made in terms of finding the sum of particular digits or taking the last two digits apart. We'll look at a few more divisibility rules tomorrow in class, or whenever it is that you get to class for this. And we'll talk a bit more about how charts like this work and why we have divisibility rules. Because as we mentioned, one of the things with divisibility rules is they don't actually tell you what the quotient is. They just tell you whether or not the quotient will be a whole number or whether you'll have a remainder. Which leads to the question that I want you to think about, and is the last thing you're going to do in your notebook for this lesson, or at least until we get to class, is to think back on the fact that this rule doesn't tell you a quotient. It tells you whether or not there's a remainder and whether or not we can do a division evenly and not get a remainder. And there are particular reasons why we might want to do this, but I'm going to ask you to start thinking about some of those first. So in your notebook, your reflection question for this lesson is, what are some examples of times that you can think of when we would just want to know whether or not there will be a remainder, or whether or not we can divide evenly and not necessarily need an exact quotient? So think about that, jot down a few ideas in your notebook, and we will see you in class when we talk about the basic divisibility rules and some of the other more complicated ones that come from them.